But really, what we're here for today, and it's really talking about these foundational principles about operating around electrical safety. Why? For me, situations like this. We start with the switchboard. So this is a switchboard, standard switchboard, 11 kV switchboard. Many of us have seen things like this. It's this. It's been returned to service. A catastrophic failure. Okay. Catastrophic failure like that is horrendous. Fortunately, on this one, there was no life-changing injuries. I'll pose the question to yourself, and you can muse that as we're talking. If that had been on your site, would that person have walked away from that situation? And that's a sobering thought when we look at things like this. So, we are going to look at different aspects of how we manage this. It's not just PPE, but as Angus knows, PPE is critical to this. But it's procedures, how we manage this and how we manage that risk and mitigate that risk. I'll ask the one other question as well. It's 35 years since electricity at work regs came out. 35 years. So why are we still hurting people? Has anything changed? Is it still electrical safety? Has the switchgear, has the equipment, the work changed? Yes, but really, has it changed? So I'm going to start now and I'll pass over to Richard Little.
Thank you, Stuart.
Let you talk about procedures and programmes.
Thank you very much. Okay, first Slido question of the day outside of football. I don't do football, so we'll go from there. Oh, back one. There we go. What is the primary hazard when you're dealing with electrical equipment? On your Slido, go for it. Lots of things have been talked about recently and through the morning. I will point you in the direction of an inquiry into Grenfell Tower. Nothing to do with electricity, but about fire safety. And anybody who's actually seen that 40-minute sketch, of which PPL do show on one of their courses, is the interrogation, and that's all I can call it, of the fire officer. And one of the items that was picked up is his lack of understanding of a basic process. So what have we got there? People, electric shock, open live conductors, well said, competency, people, electric shock, arc flash, working live, electricity, explosion, lots of stuff there. Incompetence, that's a good one, we'll come on to that in a minute. Okay, I'm going to give you an idea. A hazard is what actually is the bit that gives you the harm. So it's not shock, it's not electrocution. It's the fact that you have come into contact with something that's live. So the person who put that up there, well done. Yeah, it can be human error, but it can also be the fact that they were just trying to help. But ultimately, the hazard. So if we don't understand the basic risk assessment process, how can we defend ourselves in a court of law? Thank you. Cheers, Ben. So, there we go. What we're going to look at, ultimately one of the things that we look at while we're trying to deal with electrical processes is the safety program. I know not everybody understands that or has probably heard of it, but it's the process I've been using now for about 30 years while I've been working in the construction industry primarily. I know I only look 21, the rest of it I class as experience. We're also going to have a quick look at some of the other parts of this, some of the procedures, personal competency, authorization, and then auditing. So, where do we start? If we don't know what we're doing and who's doing it, how can we actually control it? How can we put the right steps and stages in place to enable us to actually do the work or ensure the right people are actually doing the work? Is it construction? Is it maintenance? Different requirements, different people, but ultimately, who is in charge? Who is that one person that takes the ultimate responsibility? What do we look at then? We've obviously got to actually look at what the limitations are. So, where's the point of work? What are we isolating? How are we going to isolate it? And how are we going to prove it dead? Quick show of hands. Who gets their proving units calibrated? I suggest go back and read the British Standard. You are wasting your money. If it doesn't work, throw it away. You cannot calibrate something that doesn't give you a reading. It's either on or off. I've saved a few companies money with that one over the years. What else have we got to look at? We've got to actually look at what we do with securing the isolation. How we do that, who does that, is it in the right order? And this is the whole point of what the safety program's about. So it takes it away from that, oh, I've got a switch, I'm just going to lock it off, to actually a formal procedure, because we've got to understand the protection that's in that equipment as well. How does that operate? How does that work? And if we don't get that right, we don't understand it, how can we actually move forward? Who's going to write it? It's like a method statement, but with more detail. We need somebody to check it. Point just brought up by Bill. The accepted failure rate in the nuclear industry is 1 in 100. So we get 2 people to do it. So we then identify that we actually make it better. And by doing that, you've got 2 competent people who can do the job, who check it to make sure that the people working on it are safe. What else are we looking at? What else equipment do we need? Have we got the right number of locks, the right type of locks, the right attachments that go with it? Do we need multiple hasps or don't we? How many people are working on it? Access. Do we need additional security measures? Do we just need a site induction? How do we know the people know where to go, where to meet? Is it a building in the middle of Slough, or is it a building in the middle of a field? How do we make sure they get there? Who lets them in? We're also looking at some of the equipment that we look at. If we've got lifting. Now, I'm sure there's some people out there that could lift an ACB without a problem, but is that the right way to do it? Should we use the right equipment? Has it been checked? Has it been tested? Has it been inspected? We're also then looking at potential for, transformers. Mydel oil is supposed to be environmentally friendly, but who actually likes you putting it down a drain? Do you understand your responsibilities in that process? And then obviously there's the environmental aspect of all the waste. Are you licensed to carry it away? Are you licensed to dump it? All of these aspects are what should be looking at while we're dealing with the safety program. And then we look at competency. Said on the first page, I've been using this for 30 years. Kate, apologies if any ladies called Kate or gentlemen at the weekends. Knowledge, aptitude, training and experience. If you have those in equal measures, I can prove over the last 30 years you will not hurt anyone. But if you do not apply that correctly, you're potentially going to hurt somebody. You need some form of assessment. People don't like it because it takes time. But as said earlier on today, you can't just throw somebody into a brand new switch room and expect them to operate it without giving them time to get the experience on that equipment. What else do we need to consider? The assessment. How's it going to be done? The scope of works. What are we going to be doing? Where's that element of understanding of that process? And obviously, lastly there, outside of the UK, do we have any licensing requirements that are outside of us? I'm currently working across Europe as part of my job. I'm dealing with lots of different countries, lots of different requirements. But we still use the basic safe system of work process because we know it works. At the end of it, we need to audit it. If you're the type of auditor that loves the power that goes with it, then leave. You're not the person that anybody wants to talk to. Nobody will learn. You should be there to actually ensure that people learn from what you're picking up to make sure they don't make mistakes. Training. Are the people trained correctly? Do they understand the paperwork process? Do they understand the controls? Have you looked at previous documentation? Are you looking at what people are making mistakes on, and are you highlighting that to them? And then there's the company procedures and policies. Do you have a good set of rules? Do you get somebody externally to review them or vet them? Or is it you just think yours are good enough because you wrote them? I write my company's policies, and the first thing I do is get somebody else to check them because I might have made a mistake. And on that note, I'm going to hand back over to Stuart. So thank you very much.
Thank you, Richard. Okay, so, sorry, I'm just checking I've got the right slides there. Okay, so as Richard sort of talked about there, where does this all fit together? Now, I want to talk about Arc Flash today, and where does Arc Flash sit into this programme? For me, Arc Flash is an important part of any programme, but as you can see there, it relies on everything else being in place. You've got to have the safety rules, you've got to have competent people, you've got to have training, auditing, everything like that. You've got to have a condition assessment programme, okay? You've got to have replacement and upgrades of that equipment in there. You've got to understand your system configuration. You've got to understand the short circuit and equipment capability and protection coordination studies. But more importantly, that's where your arc flash comes in. It's at the end of that list, but it's only at the end of that list because you've got to have all the others in place first. Okay. Now, I also say arc flash as well. It's not just about going out and buying PPE. But for me, arc flash PPE is probably the first and last line of defence when you're talking around arc flash. And it's strange to talk about PPE as first and last line of defence, but I'll come back to that and explain. So, I'm going to assume that we all know what arc flash is. Sorry, my slides look different to Angus's. The words are the same though. And that's the important thing, is when do we need to consider arc flash? Okay. We can't just go out and rush out and buy arc flash PP because that's not really the right answer. But we've got to do a risk assessment. But what are we going to put in that risk assessment? Is it, I'm walking into a substation, it could go bang. I'm switching on a food mixer, it could go bang. But realistically, for me, I go back to that situation, that switchgear that I brought up at the beginning. Okay. And that to me is the one that provides me with the greatest concern. Working on live electrical equipment, I class as the precautions around that are avoiding electric shock. I'm talking about operating electrical switchgear. It's a hugely different situation. You're doing everything right, you're controlling it, however you can still lead to a fault. Now, at that situation, it's how do we manage that risk? And they're the highest risk. So operating electrical switchgear at that point, and I realise I've just repeated that one, the likelihood of an event occurring is massive. I look at people and I've seen people limit access to substations, paint lines on floors in substations. Perfectly good. But as long as you're limiting access to a substation and people aren't going in and sleeping as you sort of find, the likelihood of an event happening randomly when somebody walks in just to do an audit is very, very low. However, when you're working on that equipment, you're operating it, isolating it, racking it in service, returning it service, you know that the person's there because the person's doing that work. In reality, you're changing the state of that equipment, it's more likely to fail. That's where the concern is. So how do we reduce the risk from that? Okay, hierarchy of control. We've seen it already today. Okay, it's not changed. I'm not bringing you anything new. Okay, and today I won't bring you anything new. I'm just going to give you some basic facts and simple methods how we can reduce that risk from arc flash. Okay, elimination, substitution, engineering controls, admin, PPE. It's the basic things that we all look at when we're doing that hierarchy of control. It's a little bit strange though when you talk about elimination and substitution when you talk about electrical systems. How do you eliminate? How do you substitute? The volts are there, the amps are there. How do you do that? But realistically, we're talking about operating equipment. Okay? So the question around operating equipment is there a way we can operate it where that supply is not there, where it's dead, where it's isolated? And it sounds strange to sort of say that because that's probably the activity that you want to do is make it dead. But is there a different way, with careful planning, that you can change that procedure? Okay. Sorry, I should have read them, Angus, I apologise. So elimination, not substitution. Okay, I brought up here a simple line diagram. Okay, I'm looking at taking this equipment out for maintenance. So I want to isolate this bit down here. Okay? Normal convention. If you go on any switching program, any course around switching, they'll tell you to start here and work your way back up this string. Start here, work your way back up this string. Okay. Dead simple. But every one of them activities is on a piece of live equipment that we're going to go and operate. Why can't I operate this one up here? This one here. If I do that, I remove this risk here, because then I can go operate them dead. Am I not eliminating the risk by doing that?
Historically, everybody's told to remove the load before you switch.
Absolutely, 100% right. And exactly that's what we'll do. We'll remove the load from here. You've got volts on the system. You've got no load, and that's absolutely right. You don't just go switch the MCC off when everything's running. Gets a lot of operators running in the substation. A lot of angry people, believe me, I've been there. Okay, but yes, we can do all those preparations here. We can switch all the load off at this point, okay, but it's operating the switchgear here that we can do at this point. And that removes that hazard around eliminating that risk. Okay. We can do that about putting it back on as well. Okay. So that's easy enough to implement to isolate that equipment, but returning it back to service. Normal convention would have been start up here, okay, put the HV on, start the incomer on the ACB board, then outgoing waves. Again, but is there any reason? Why are we doing that? Is there a reason that we do that? Historical convention. Why couldn't I close all them up and then go up to this point and close my HV breaker? If I do it this way around, instead of switching 1, 2, 3, 4 breakers, I'm only switching one that's live. So I've reduced my situation by 75%. So by doing nothing other than changing the way you operate your switchgear, which order you operate it in, you've reduced your likelihood of an arc flash event by 75%. That's not bad going, is it? It's fairly simple. Okay. People talk to me about, well, can you actually do that? Concern about switching this network back on, and you're right about load, but when you put this on, you're not putting load on the system. You're putting volts on the system, you're not putting load. So we can do that. It doesn't add any additional risk, and it works. Okay. Other things that we can do. Engineering controls. Can we do remote operation? Because when we've got that HV breaker up there, we're still there and operating it. Can we change how we operate it? Because you've still got that actual standing in front of the breakers. And sorry, I'm old. So in my early careers, we're standing in front of circuit breakers and operating breakers and pressing the buttons directly in front of them. Okay. I started thinking about that when I got a young family and thought, is this really the right way we should be doing this? And this is where we came to this. And say we've done the elimination. Now we came back to engineering controls. And actually, can we introduce remote switching? Because if I can introduce remote switching on that HV breaker, then where's my risk? So there's lots of opportunities for putting remote switching in. This one here, chicken switches, I think the American friends call them. But again, there's lots of variations. And realistically, I'm looking at retrofits for old equipment. Most modern equipment that we're purchasing these days should have remote operation facilities. It should have, and it could have. Okay, that's important. They could. Okay, so that's when we are specifying equipment, make sure it's specified in there to have remote operation, not just manual operation directly in front. So by doing that, putting that remote operation in there, it does take some investment. But realistically, to put something like that, that's not going to cost us a lot of money, is it? And the risk we're mitigating is very, very significant from that. So it's a simple step. You can also coordinate it with your maintenance activities, so you don't need outages. Because, yes, it takes time to implement that, but simple enough to do as part of your programs. Okay, so we've got elimination and engineering controls. Say, open that circuit breaker from the top end. Eliminates and isolates that whole leg. So then we're not switching down here. We're going to switch up here. I'm going to switch it remotely. Okay, so I'm going to be stood outside the substation. So when I talk about remote switching, when we implemented ours, I got a switch box. And I thought, what shall I do with this switch box? I sort of said, I could write a procedure and actually say, tell the guys to stand outside the substation. And I thought, well, actually, why should I do a procedural control? Why don't I do an engineering control and actually mount that box outside the substation? I know exactly where they're going to be when they switch it that way, don't I? So simple steps like that don't take a lot of effort, take a little bit of thinking about, can actually build that safety for us and actually get us to the right situation. Okay. Sorry, there's a formula. We've got a few engineers in here today, so we can accept a few formulas. Okay, all right. Nobody's mentioned the arc flash calculation. It's a dead simple one. Instant energy is directly proportional with volts, fault current, time, and distance squared. Okay, so we've got voltage, which is your system voltage, I, which is your fault current, T is the time that the event will be happening for, and D squared is the distance you are away from it. It's not complicated, okay? But realistically, now, we have a situation of how do we change this? How do we reduce that incident energy? Andrea, I don't know if you've disappeared to, but you mentioned it earlier. If we altered this time factor here, okay, we can make a big difference. We talk about instantaneous protection and actually implementing instantaneous protection on switchgear. I had a conversation, I think it was lunchtime or break time. Somebody was mentioning to me, well, no, the protection settings are already set there. Okay, we've already had the engineering settings put in the system. That's what they are. We can't just go change them. We aren't changing them. What we're doing is putting a temporary set of settings in while we actually operate the equipment. They're not there for its normal operation. It's while you're operating that equipment, and only while you're operating that equipment. Once you've operated it, you put it back to its normal settings. Okay? The worst case scenario is it trips before you switch it. So what? It was coming off anyway, weren't it? Because you're isolating it. Okay. The others are hard to do much about. Distance squared, or distance. Well, I've done that by doing my remote operation. By actually being stood outside the substation, I've moved myself away. I can't do much about the voltage and the fault current. They are a factor of the system. Okay. Arc flash modelling gets a little bit more complicated, this one. Okay, nice drawings in there. So what we're looking at here is a fault and a 415 switchboard. So I've used the ETAP software to model this one. Simple sort of system in there. I've got an 11 kV transformer, 11 to 415 transformer. Works out the incident energy at that one is 70.29 cal. 70.29, if anybody's not done any arc flash calculations, is quite high. Okay. On site, we set a standard to have 40 cal PPE. 40 cal is significant. Above 40 cal, you start questioning the impact and the blast energy that people will receive during that, and whether that's survivable as well. Okay, so when you start looking at different levels of PPE, think what's an acceptable level in there. Okay, distance in there and everything else, okay, are just standard formulas that are put into the system. What we then looked at is changing that time setting. So as I say, we're at 70.29 cal there, okay. We implemented instantaneous protection on that system, just while we're operating this equipment, okay. And this was actually an MCC with a withdrawable starter. So a nice modern MCC, withdrawable starters that we have to plug in and pull off and plug back into the bus bars, okay. And we recognise that during that activity of unplugging and plugging back in, the workers, the operators, the technicians are actually exposed to a very high fault level. So we said, what can we do? We implemented this instantaneous protection, okay. Our fault clearing time came down from above 3 seconds to 0.074 seconds, give us an incident energy of 2.91 cal. So we've gone from 70 cal to 2.91 cal, okay. It's a hell of a change, and I haven't spent any money on that. It's just a setting that I have to put in just while we're doing that activity. Okay, so when we talk about arc flash and the costs, I think somebody threw some answer or some questions out earlier about, is it worth it? Well, is it or not? The challenges we're putting here aren't expensive. You need to understand them. You've got to have a study done in there, but the actual follow-on isn't expensive. As I say, by doing this, a 3 cal event, and I'm still wearing my 40 cal suit, I feel a lot safer. I feel happy to put people into that situation, because I can't ever get rid of that residual risk. No matter what I've done here, unless I operate everything dead, I can't get rid of that remaining risk. Okay, PPE, I said, is it the last line of defence? Well, I'll challenge this. Everybody uses them words. For me, in arc flash, I actually think it's the first line of defence, which is always a challenging statement. But no matter what we do with arc flash, we will have some remaining residual risk. We can't get rid of it, okay? Somewhere in there, we will have to switch that system live. Some part of that system, we will have to operate live. We can't not do that. So what do? We put PPE in. We give people PPE. So should we wait while we've done all these steps that we've talked about and present them with a nice shiny set of arc flash PPE at this point? Or should we recognise that actually we are going to have to put arc flash PPE in place? Okay, we set a standard what we should be doing, what we should have in there. As I say, we picked up a 40 cal standard. That's our corporate stance, that we do not work above a 40 cal event. We put a 40 cal arc flash PPE in as our standard. We issued all our technicians that 40 cal suit. Okay, so if there was an incident, any time from us implementing the arc flash PPE to fully implementing our program, they are safer. There may be situations where that arc flash suit may be exceeded by incident energies, as should. We had 70 cal events. I'll say though, if I'm stood in front of a 70 cal event, I know which I'd rather be doing. Would I rather be wearing that 40 cal suit or my standard overalls? And I know what the answer would be. So I'd rather wear that. So that's why I sort of say it's the first and last line in defence for me for arc flash PPE. It needs to be put in place. Okay. The challenge is knowing when and where to wear it. When you're wearing something like this, a full beekeeper bomb-proof suit, you're not wearing it long term. Okay, this is operating switchgear. Okay, that's all we're talking about. We're not asking anybody to wear that for 8 hours. This is 20 seconds while you throw a lever, press a button, things like that. You're not doing manually dexterous work wearing that. It's limited times when you're wearing it. Okay, so once you've done all that and you've got your arc flash study, I'm going to sort of say that you need your results in there. You need to understand these results. And actually you need that policy. You know, as Richard talked about policies and procedures, you need to get that policy and procedures and actually publish the results. Okay, I think Andrea put the labels up again. But they all follow a common sort of format in there. You know, we've used the red, amber, yellows. Okay, red, you've exceeded the rating in the suit, so you need to do something different. Okay, amber, you're in that higher sort of level. Yellow, you're in a lower sort of level. Blue, okay, we've classed as below 1.2 cal. But what we need to do is train the people. Okay, there's been some questions coming through on the Slidos. How do you get people to wear this suit? How do you get people to wear this PPE? Effectively, you've got to educate them. Okay, you're the engineers, you're doing the design work, you're writing the procedures, you're writing the policy. You understand it all. Okay, you've got to condense, understand that knowledge, and actually share it with the team so that they understand why they're doing it. Okay, it's not simple. Okay, but it is important. Okay, the important thing as well is this: is in labelling all the equipment, labelling all the relevant equipment, so they know what they're doing in there. Okay, when it applies, when it doesn't apply. How does it change if you alter that system? Make sure the people know what those changes mean. Okay, so I'm going to summarise. Okay, keep it simple. Okay, most of what I've talked about here doesn't have a high cost. Okay, it's basic stuff. Changing the order that you operate your switchgear in. Okay, operate your HV breaker before your LV breakers. You eliminate so much risk by doing that. Okay, so I operate it dead. If you can't operate it dead, operate it remotely. You know, remote operation and remote upgrades, okay, aren't an expensive item. I know I worked, because we implemented this 15 years ago. I went back to the manufacturer. It was Alstom at the time. There's now Schneider. Worked with Tom Lavin, who was there, and I think Tom's still there at the moment. We developed a retrofit HV circuit breaker. Okay, we took the opportunity to move from oil circuit breakers to vacuum circuit breakers. So get rid of that older oil technology, move to vacuum circuit breakers, but put a retrofit on there so that we could operate it remotely. It's dead simple. Remove us away from that hazard. As I say, switching box on the outside of the substation. I know everybody's outside of that substation when we're switching. We even bought remote racking trucks. So we could actually have a remote racking truck sat in front of the switchgear, and again we could go stand outside that substation and rack it up and rack it down. And it really removed us from that hazard. Okay? The other thing in there, you need that arc flash study. Okay? I asked earlier about how many companies or how many representatives have done an arc flash study. If you've not done the arc flash study, it's something I think, well, something I'd recommend doing, because you don't really understand where your hazard is unless you're doing that arc flash study. But if you've got all the other pieces in place, it shouldn't be an onerous task. It shouldn't be an expensive task, Because in reality, if you've got a protection study and an equipment study and you've got everything else like that, it's one more button on your software. Understanding the results from that take a little bit more effort, but actually implementing those improvements aren't particularly difficult. Okay, and as I say, PPE, first and last in my mind for arc flash, because do you want to be that person thinking, yes, I know I'm going to issue some arc flash, but I'm going to wait down here until I've completed my whole program before I go give out this arc flash? What happens if there's an incident here? You know you're not going to issue the arc flash PPE. Why not issue it at the beginning of your program? Bring everybody on board with your program. Explain to the teams why you're doing this arc flash program. Don't just give them the end result. Get them involved so they understand it and they buy into it. Okay, and that's my bit done. Okay, Stephen. There you go, Stephen. Thank you.
Right. Okay. Ooh. Sorry, it seemed like a blackout. I've broken it now. Okay. Hang on. Imagine you're first on the scene. The lights have gone out. There's a massive explosion. There's people screaming. There's smoke billowing out of a switch room. There's fires going on. Are you able to help? Are you able to go in and effect a rescue? I've been in this industry for a long time, and I've investigated lots and lots of incidents. My journey started about the early 80s. When a good friend had an arc flash incident. Recently there was one that I investigated, and there was a common theme that I was picking up, that even though these guys were really good electricians, they did nothing wrong, but unfortunately they were in the wrong place at the wrong time, and there was an arc flash incident where their lives were changed. But one thing in the investigation I sort of discovered was the people around just didn't have a clue what to do. It's an experience that you probably would never want to have, is where you've got these people screaming for your help and you have got nothing prepared. So what I'm going to talk about is the preparing for that, hopefully, incident that will never happen, and have the right information and the right equipment to hand to help the situation. So I'll go through the incident there. Some people from Hanson may understand where that is. But anyway, one of the things is about training the people who are working on the electrical systems, and also the people that are working on the plant who might be affected a rescue. And it's just having a think about what you need to do. So things like the who to call, how to do a rescue are really important. Having the right equipment, the rescue hooks, the first aid kit, voltage testers, because obviously you don't know the situation. Has the power gone off? Has it been put back on again? You don't know, so having that in place. And the training also, I think what you need to do is include the fire services to maybe come in and help you sort of do a little rescue situation and practice rescuing people from electrical switch rooms. I've seen so many rescue plans that have been like to take people out of a confined space, out of a building, down some stairs, but I've not seen one yet where it says about how you rescue somebody from an electrical switch room. The second person, it's really important to understand that the second person is going to be the first on the scene. Generally, he's going to be standing outside. He needs to know where to isolate those things. So having the right procedures in place, written down, practice, and go through the situation that, you know, if something happens, you need to switch off. So being prepared for the worst case scenario is so important. Raising the alarm. I mean, time is the essence on this one, is that you need to get help as soon as possible and get them to the right place. So I'll talk in a minute about the kind of information for that. But having all that prepared beforehand is going to make the recovery of the person far better and more chance for them surviving. Just one thing. The bottom one there, of course, about the rescue is that obviously you don't put yourself at risk, because it's a situation, you've got black smoke billowing out, fires, you don't know whether that equipment's alive. So it's about keeping yourself safe as well. So this is why you need to practice these things. One of the things that we developed at Breedon before I left them is a rescue station. So at each substation there was equipment that was available with all the equipment that you need for a major burn, explosion, and how to protect you. So within that pack, the next slide will show what's in this pack here, what we have. And one other thing, I talked about one of the incidents that I investigated where the electrician had an arc flash incident. He was laying on the floor screaming, and they came in to try and rescue him. They didn't know what to do. So they got a CO2 fire extinguisher and they were spraying him to try and put him out, and that was fine. As soon as they stopped, because he couldn't breathe, it ignited again. And that's why I've put the water in there, so we got water that we can try and cool the body down. And so every substation we have has got one of those rescue stations. And with the aid of Scanware, they've also done a portable version of that, where you can then move that to the substation you're working on, especially if you've got a very long switch room that you need to cover the whole thing. You can just drag that to the job, and it's got all the equipment you need to do the rescue. We sort of thought about, from the investigations, what do we actually need in that situation? And so the main things I've got on here is obviously some safety gloves. There's a rescue hook, of course, visors and gloves, because we don't know whether that's alive or whether it's going to reclose. So having that equipment, having cling film available, it's something that you can buy so cheaply, but can really help the burns in the long term, and the first aid kits, etc., and mouthpiece. So there's all those sort of things that are really important. But this is probably the most important things, and it costs you nothing. Well, small amount of money. It's about having the right information at the point where the emergency's happened. So on every substation door, we have one of these panels, and it's just a traffic engraved board which says the address. Most emergency services now use what3word, and I got the coordinates for where the actual substation is, so they can come straight to that point, no delay. The site emergency numbers is all there. The nearest A&E, the supply company, and the telephone number, and what the substation switch room ID is, so that information is readily available on the door. You don't have to go around finding equipment or what the substation's called or where you are, because you may be the first time that you've been to there. So having those on every door just makes the information sort of work for you. And that was really all I want to do is really, can you really think about, in your procedures, have you got a rescue procedure, and have you got the equipment in place to help somebody in the event that all the other measures that everybody's talked about has failed? This is what happens when things go wrong. Okay, Stuart?
Hey, good afternoon, everybody. Today, the main thing is that we have a lot of fundamental electrical safety system all over the company or industry, actually. My point is, from my experience, particularly in service industry, I try to cover, we still do have accidents happening. What some of the insights, why we still get these accidents based upon sharing my own experience, probably. So if in my company, if I see that we collect data either through as a reactive one after an incident or through audits. We get implementing generally electrical safety fundamental principles. In ABB, it's almost like 7 steps. Or we do trainings. We used to have classroom trainings. Moreover, we also try to motivate people by introducing hands-on practical training centers. Procedures, process, safe working procedures, implementation of lockout, tagout, all those things getting implemented. Competency assessment, we try to assess which level, and we do in service, we do product business also. So we have individual products like drives, motors. We try to categorize what type of competency or how you practically apply your competency in each product actually. PPEs, yeah, I have seen industry where people go in big shirt, tie, everything to a service industry. That's not what we needed. The right type of kit, we try to design tools, PPE, which is applicable for them. Then management of contractors, still a question mark actually. Still, we have a lot of issues with that actually. So we don't really know how to tackle the contractors' competency actually. More or less, when we have such kind of programs, we notice that incidents have considerably decreased. And we can proudly say that where I am coming from, 90% of our serious injuries or fatalities we used to have been completely, or touch wood, from 2016, we don't have any serious injuries or fatalities from that point. Now why do incidents? No, why we are having incidents again? Some of the incidents I'm sharing is related with product-oriented business, where one service engineer is going to a customer site, dealing with the customer people, dealing with them, how they do the carry out a service or maintenance job, or even troubleshooting job actually. Some of the incident sharing is that you get isolated. Most of the time the isolation is done from the customer. And our person in charge of work try to verify where the point of isolation. He tried to make sure that it is properly grounded, it's locked out, tagged out, he applies the lock and all those things. Now, the customer is normally telling that it is being isolated now, it's your baby, now it's your panel, you go and do the job. And even when we go there, if he is isolated, he's not properly cross-checked or something. Like particularly a product we have in commerce coming, like cables, something drops down, it's human instinct to go and pick straight away, right? So repeated incidents, like we can see that similar type of incidents happening, irrespective where you are in the world actually, it happens all over the world actually. So it brings to a question mark why again incidents are happening, right? Now, are we not following the basics? And the reality is that we are not really following the basics actually. So where the competency? So we try to analyze from the top level what is missing. Company competency, and I'm talking about a manager. Sorry if there is any service manager or senior management. What we have noticed is like everybody is having a target. You need to achieve 100% resource they have been working. Let's start with training probably. We have been hands-on practical training. Now since COVID has completed, everything moved to e-learnings or virtual trainings. We really don't know. First 2 years went very well. The third year, again, we started that. The virtual trainings or e-learnings are becoming a tick box exercise. It's not really giving the purpose when we had a hands-on training or something like that. Again, from the company competence, we used to have a contract when it comes to service, supervision of installation, testing, and commissioning. So what is this supervision of installations? So let's say one medium voltage drive gets commissioned in 1 week of time. We used to cross-check point-to-point checks where the cable is being wired, the functional test of the breaker, all those things are being checked. Now, cutting corners, we try to commission the drive in 3 days. So basically we try to check only what the contractor or who is being installed if is done. It's like a paper box, tick box, or a Welber communication. And you try try to start drive A from a breaker perspective, drive B gets started. And it's a basic fundamental wiring error, which is done by a contractor we are not able to trace out. Ultimately, a huge loss because the product is under warranty. So such kind of things are really happening. Employee competence, which is related to contracts and pre-tendering. From the perspective of employee competence, I'm an old school guy, probably. We used to work in site. We have seen schematics, single line drawings. I've been taught never touch that, all those things. But the youngsters, what I am seeing is that they are very good in computers. They know parameterization. Everything can be done in computers. They are super fast. But in reality, and we have combined with the virtual trainings, when they go to the site, complex environment, they completely forget what they have learned, and they just blindly believe the customer on the isolation, switching, and all those things, actually. So this is also another experience, training, and auditing. How frequently we audit those sites. Nowadays, nobody has got time to go there and see the sites. And audit is normally done by HSE people also, who doesn't maybe having a electrical competence. Then it also becomes a tick box exercise. Employee engagement. This is also very important part. The nature of a service engineer, he goes from the home to the service site, he comes back. He's not really connected with the company or the organization, or the manager is not really engaging them, what exactly he's doing. I did an audit recently in one of the sites in UK. I just don't remember exactly where, actually. So what I have noticed is that the complacency pitching, if they don't feel that they are a part of the organization, automatically they are more connected with the customers, the customer systems, and most of the time it works, actually. And they blindly started believing the customer, actually. So lockout tagout process, sources of re-energization, or from a backfeed or something, or using of PP, they cut the corners, actually. So, and more or less, they don't feel that they are a part of the organization. These are some of the things we need to really address in those situations, actually. So these are not new issues, I know that. What procedures do you have? And probably these are some of the things we need to make sure that what's stopping you to close those gaps, and has this been raised more questions or gaps or anything like that, yeah? That's all I want to address today. Thank you very much, yeah.
Thank you, Joby. Thank you. Okay. Well, I was sort of sat there. I wasn't doing my Facebook updates. I was checking the Slido questions coming in. So just a few of them. Ben, can we get the Slido questions coming up? There's a comment there about Richard. You mentioned about the voltage indicators being calibrated. There's a statement there that realistically it's a verification that the device does work when it's required to, will withstand that system voltage that it's going to be potentially exposed to.
The point there is to identify that ultimately the whole point of proving unit is you prove it with the actual unit, say that it's at a voltage taken away. What are you calibrating? And when you actually read the British Standard, it clearly says it is to be inspected, not calibrated. So when you look at that, are you just wasting your money? Now, okay, if you've got a specific test meter that you're using as a test meter, I understand that. But if you're just for proving, why are you wasting money? But that's down to you guys, obviously.
Sometimes the client actually requests that from a health and safety point of view. Show me your calibration certificate. Very difficult to explain to a client who doesn't understand that proving it in itself is a unit that self-calibrates. It's either on or off.
Understand that, and I appreciate that. At the moment, the company and the people I deal with, I've got about 300 different clients. I've never had that question yet, but I appreciate there's that. But if you've got to do it, you've got to do it. Yeah. But my question is, the amount of money that we've saved over the years from the teams that I've been working with, that can go into something else and actually make it worthwhile. But when you read the British Standard, it clearly says inspect, nothing about calibrating.
I think it's probably more involved with HV. Sorry, I think it's probably more important when it comes to HV that you've got to make sure the kit has the dielectric strength. Whereas how can you actually check the leads, etc., are still safe, that the actual part of the handle that you're holding is still safe without putting it through a proper calibration?
Calibration is to make sure that it gives a true reading.
Yeah.
It's not, in HV equipment, as far as I can remember the last time I did it, you apply bongs to it and you get a light. There's nothing to calibrate.
I think it's actually what we're playing about is terminologies of words. I think you're both right. Okay, calibration is one aspect of it, is to validate you are getting a true reading. But with a proving unit, you're absolutely right. You've got to ensure that it will withstand that system voltage that it may face. So there is that test in there that we've got to prove that it will still be safe to use on that. Because yes, you are proving dead, but if something's wrong, you may put it on a live system as well. Yeah. Okay, so there's two aspects of that one. So good conversation on that one. Some more questions coming in here about, unless there's another one from the floor. If we've got small to medium businesses, how do they manage and understand the risk of doing maintenance and understand the requirements of doing maintenance? And then from that, how do we build in, how do they take on board doing an arc flash study if they've not had an incident? So, Stephen, I'm going to throw that one to you.
All right.
So, small to medium businesses, how do we mitigate that risk, or how do we ensure that we carry out the appropriate maintenance? Because, as we've talked about, maintenance gets extended and extended. How do we ensure we're doing it at timely frequencies?
I guess the main thing really is about education. So it's about finding the right consultant who can go in and explain what the reason for that and what the benefits would be. And then obviously the enforcers, Mr. Bill and his crew would do that. But yeah, I think it's about education and just going in and just talking through what actually is required. And yeah, it's going to be an expense, but
Yeah.
you can phase it.
It is, it's difficult, and I think education is one of them key points, which is part of what we're doing today, but obviously we're preaching a little bit to the converted at this sort of place. There's a comment in there about we're actually a race to the lowest competence in there, but actually I think it's lowest cost that we're sort of chasing at this moment in time. And the lowest cost bidder tends to win the work, and we've got to be responsible as our care as duty holders to ensure that we get the right status in there. There's some challenges as well about how we manage from working from a construction to commissioning to operating. And I say, my situation, I've come from an owner of a plant and how we manage that. I recognise that there's a whole raft of different industries in there, going from that construction, commissioning, energisation, but also the maintenance teams coming in. How do you manage a maintenance team that's coming in to manage your work? If you're the owner of that company, how do you protect your workers? Richard, I'm going to pass that one to you.
Sorry, say again.
So, exactly, I know. Yeah. So, as a owner of a contract company going onto a site to do work, how do you ensure the safety of your people when they're working on site? That site may not have considered arc flash.
First thing, thank you. Is that gone? First thing, obviously, is the competency assessment. As I said earlier on, unless you have a good process that you can validate through audit and through time, how do you know anybody's confident what they're doing? The next thing is, obviously, from my perspective, is that safety policy and process, which is the safe system of work, which gives them the boundaries to what they work in and what they can't do. The second thing is the A in the K is their aptitude of that person. It's very difficult to assess that as part of the process, but part of that actually is ensuring that if they're not happy, they're not sure, they know they've got somebody to call back on. And that's where the AEs and myself sit back in that where we need be. We also have to give them the confidence to say no. And they must be able to say no, knowing that it's not going to affect their job, their position, or what they actually do, and that we will support them. And as managers and directors, we have to support our teams on the ground, because if we don't, they're not going to have the confidence to do it. And one thing I hear quite a bit these days, I don't want the responsibility because, I'm not getting paid for it, or nobody's going to support me, or I'm going to lose my job. And if we have people with that attitude on the ground because we're not supporting them, that's what we're going to expect.
Okay.
Top question for which Stuart.
Yep, sorry. Go on, what? I can't read that one, apologies. It's a really funny angle I'm stood. Would you promote the use of safety documents, i.e. permit to work sanction for tests on LV systems? I often see safety rules that negate the need for safety documents on LV. Joby. So, these documents, sanction for test, permission to work, and limitation of access, I've typically seen under HV systems. But under LV systems, I've not particularly seen them. What's your thoughts on these?
Yeah, most of the safety systems are starting from 1000 volts actually. So, but in reality, this is very much applicable in low voltage systems actually. So, particularly permit to work. I have seen that people take it very lightly when it comes to the permit to work, when it comes to low voltage systems, where it is having a single point isolation. People completely neglect it, which is reasonable. But when you have a multiple source of isolation, it is very much needed actually. That's, yeah.
Okay. All right. Top question on there then. How do we justify the expenditure on arc flash PPE if we haven't had an accident? It's a real tough one. I think that's a real challenge for all of us. But as engineers, we've got to understand what the risks are. But we've got to sort of mitigate it. As I was saying when I was presenting, we're talking about a small operation window. Okay? A small operation where we're going to have that arc flash PPE or require people to wear that arc flash PPE. Different activities on your site will need assessing to understand where that risk is. I highlighted that on our site to say that is what I see as our biggest risk. That's our biggest risk that's uncontrolled. I can't have procedures or don't have procedures to do anything else like that, which is where we implemented PPE. That's where we implemented remote racking, remote switching facilities. But I appreciate they will cost some money. But some of the other measures I put up there were free. Operation switchgear. Change the sequence of operation. Don't start at the low voltage side and work your way up. Isolate at the HV side. By that, you've reduced a huge amount of what you can do. Change protection settings. Okay? We can reduce those protection settings. But you still need to do some sort of study in there. But that's part of being an asset owner to get to that place, to understand what your asset is, what the risk is you're facing. Let me do it a different way. I like doing little analogies. Okay. Who's got kids? Hands up.
Unfortunately.
1, 2, a few of you. Would you be happy having your kids in front of that switchgear and operating it? If the answer's no, then we should be doing something different, shouldn't we? Is that not the solution because they are somebody else's kids? We have a responsibility. Okay. That's also a sobering one, that one. It just, but it's true. They're somebody else's children. Okay. How are we doing for time, Angus? Okay, there is one more, which is our rainbow socks, arc socks, a prerequisite to wear. Unfortunately, we only had 4. We didn't know what to do with them, so we went for pairs. Okay. All right, thank you on that. There's lots and lots of questions. It is a very large topic. Arc flash, there is a lot of, I sort of see as misinformation, misnomers on there. People talk to you about arc flash and say, do a risk assessment. It's more than a risk assessment. It is analyse where your risks are. Everybody can do a risk assessment, but be sensible. There are limited times where you face an arc flash situation, but manage those risks properly. That's what I'll say. Okay, on that, I think we'll draw this section to... Yeah, we're to break now, Angus. All right, thank you. We're at another break, so thank you for that. Half an hour for this one? Brilliant, half an hour back upstairs. Thank you, everybody.